Well,
Greetings,
good
everybody. Oh, sorry, Dave.
Okay. I thought you wanted me to start, my man. That's what you said.
No, I just
So
wanted
go.
you to press the button. I'm sorry.
Oh, okay, then I won't say a word. Then I won't. Yeah.
Okay. I'm John. That's Dave. That's Jason. I'm going to shut up and let Dave take over. Okay. That was my sole role today.
You're done. See you later. Goodbye. You can
I'm
log off
done.
now,
I'm done.
brother. All right. Good morning, good afternoon, everybody. Joining us for another edition of Takeo Tuesday, and today we are on a residential focus, and we are going to be talking about zone valves versus zone circulators, and which one is better, and the be-all, end-all debate of them all that we see out there when it comes to discussing zone valves versus zone circulators. So this will be on a residential side of things as well. We'll be here for the next hour or so. But before we get started, just want a quick question for everybody out there. Make sure that you can see, hear everything here. Give us a quick hi, hello, how are you, or where you're from in the country right now. So this will also know whether it's morning or afternoon or evening for some of you out there. So Ernie, thank you very much. Hello, how are you doing out there as well? So I'm assuming you can hear me. That's a good thing. We've got a bunch of you online today, so which is a really good indicator of maybe you're not sure which one is best, whether you zone by zone valves or zone by circulators. I'm going to pull up a poll in a couple of minutes, so this way you can answer to ask and answer which way you think is best. All right, so Mike from Jersey, excellent. And if you're not sure how to communicate with us, you'll see your toolbar on the right hand side. If you see the orange arrow pointing to the left, click on it, it will turn to the right, and you should be able to see a question/chat function. If you're on your phone, things look a little bit different. It's going to be along the bottom of the screen itself in order to communicate with us. Joel from Chicago, excellent. So still morning for Joel. It's the afternoon for Mike in Jersey. All right, for myself in New York, and John, it is afternoon for us, and for Mr. Jason here, it is 9 o'clock in the morning. Yep.
Breakfast.
So yeah, it's just after breakfast. No tacos yet. No tacos yet. Breakfast tacos.
And
Yes.
I don't know for everybody else, but I know, Dave, for you and me, it's hot and humid and sticky. And it's been that way for a couple of days. So let us know what the weather's like in your part of the world too.
Yes. And we're talking heating systems in the middle of the summer.
Yeah,
yes.
I know. Crazy talk, right?
So with that being said, let's get this slideshow started, right? So zone valves versus zone circulators. This conversation, and I've been asking this since I started here at Takeo 13 years ago on what everybody's preference is, all right? Whether you zone by zone valve, zone by circulators, everybody's got their own personal preference, right? It is a huge debate that I think will never, ever, ever go away because everybody's got their own personal preference, as in over or under, all right, when you're putting that toilet paper roll together, right?
Over.
John's an over. Jason's an under. I know he is, right? Jay, you're an under? Nope, can't hear you, brother. Oh, you were muted.
Sorry, I was muted. Yeah, I'm an over.
Oh, okay. I assumed an under just because I thought I've seen cats in your house before.
No.
Or at least you had a picture of a cat, so maybe.
Oh, yeah. A stray cat.
Yeah. Okay, I got you. So, but yeah, this debate goes on forever and ever. So what I want to do real quick, all right, I want to ask everybody a quick poll out there, right? So, and polls are made up 98% of the time on the spot, so I did throw a poll out there. So let me do a quick launch of that poll. All right. And if you only had one way to zone, I got to hit the word launch. Sorry. All right, let's make sure what everybody sees out there. If you only had one way to zone a system out there, all right, how would you design it? All right, what would you design? Whether it's going to be zone valves versus zone circulators. So we've got a few people coming in there, typing in some answers. I see some zone valves. I see some circulators out there. I do see the third answer getting checked off there. You only had one choice. One choice.
It depends. It's not an answer.
Trick question.
I had to throw that in there because there's always a lot of people that will say it depends out there when it comes to zoning their systems out there, right? So right now, all right, we're about 45 minutes into it. Looking at, wow, this is very interesting, John. My
Very.
numbers that I'm seeing is at the moment 64% zone valves.
Yeah. And I'm a
That's
little
high volume.
disappointed in voter turnout here. Okay. We only have 38% of the vote tallied.
Okay.
So folks, take a stand. Let's go.
So now it's starting to creep up a little bit as they're seeing. And Michael, he did post it in the question area here as well. So, and hopefully you saw the way the poll is. You just should be able to do it right on the screen itself, unless you're on your phone. And I'm not sure how things answer out. So not everybody gets to answer because of depending on what platform they're on. I know it's challenging on some devices when you're out there. And Shannon's going zone circulators. All right. So let me close out that poll. We've been at it for over a minute and a half. All right. And I think I should be able to share it with everybody, right? So yes. So this is
Wow.
what we ran into. We see a lot of zone valve systems out there. Really surprised. Really
Yeah,
surprised.
that's here in the Northeast, we tend to zone with circulators
Yep.
for whatever reason. But as you move further west, that does shift a little bit. So this is an interesting response to the question.
Mm-hmm. Mm-hmm. And you know what? I have seen those numbers go up over the last couple of years, at least the last 5 to 8 years or so. It was always zone circulators over zone valves for years, and it's been
Mhm.
slowly creeping up. I think as we also see the advent of our variable speed circulators out there, and other influences, so to speak, because when I first started doing this 30 years ago, when I started doing radiant designs, me personally, I was a zone valve guy, and I designed around zone valves only because I knew this thing was a big pump. It had a lot of capacity around it. And when those people left my office, or when they came in and saw my blueprints and my designs I put together, they said, "Well, I'm a pump guy. Why? Well, zone valves suck." Right? And that was all they knew. Right? They just didn't want to design around a zone valve system. They were so used to zone circulators. So it was just whatever you were used to and what you were shown when you first got involved in the industry itself. So, but when in reality, which one is better? It comes down to personal choice. All right, and it does come down to doing the math as well. And we're going to go through that today as we kick it out. Right? Let's see. Oh, there we go. So they are both good. The biggest thing to remember here is that we're not necessarily doing zoning for somebody's house, right? In my opinion, homeowners are looking for more control because there is no such thing as normal number of zones in a house any longer, right? It used to be one zone, maybe one up, one down. Maybe you got two in a house. But today, the number of zones there is no normalcy behind it. I've got 7 in my house. So when I renovated the house 10 years ago, I put a zone in practically every room if I could. And I have a mixture of both as well. And I had to do that too, just because of piping scenarios and things that I was putting together. There are differences whether you zone by zone valve or zone by circulator out there. And everybody's got their own reasons behind it, right? The most important thing is that you got to do the math. You have to do the math first, no matter what. And I think sometimes the math, the dollars behind it outweighs the math sometimes, and people just go, "Hey, this is what I've always done. I don't need to do the math," but it may cost more money one way versus the other. It's just, again, got to do the math first to know for sure what you can do. So what we do need to know is the flow and the head loss of the zones that you're working with. All right. So before you even decide on whether it's a zone valve or a zone circulator, you need to do the math first and find out what the flow and head of that one zone is going to be. So let's do a quick example. Let's say you've got a fin tube baseboard zone. It's 28,000 BTU heat loss, which is about 50 feet of baseboard. So depending upon the manufacturer, it's going to be about 50 feet. So it's a pretty big zone when you stop and think about that. 28,000 may not sound like a big number, but when you apply it to the baseboard that's there, then it seems pretty big. And then we're going to jump into the universal hydronics formula. You guys have seen this many, many times before where it states GPM equals BTUH divided by delta T times 500. So we have our heat load. We're doing baseboard, which operates on a 20-degree delta T. We're going to keep it at 100% water. So therefore our constant here becomes 500. So you do the math, you break it out, it becomes 28,000 divided by 10,000, and your flow rate is 2.8 gallons a minute. That's all you need. That's our total flow rate for this zone. All right. Now let's say we are going to zone it by circulator, and we have to go take a look at pump charts and stuff like that. But then we got to go figure out the head loss. And we're going to do head loss the easy way. So, but one thing to remember here is also what size pipe are we using here? So before we start calculating our head loss, we do have to calculate and figure out what size pipe this is going to be done in. And probably, there's some formulas that you can do, but there also is a lot of charts that are safe, trouble-free designs. Whoops, I'm sorry. So here we're probably going to use 3/4 inch pipe. All right, that's going to get us our safe, trouble-free design because 2 to 4 gallons per minute, 3/4 inch is all you need. We're at 2.8, so safely there. So in order to calculate the head loss, knowing that number, now we're going to estimate this on the high side because we need to know how much pipe is there. The only thing that we do know is about 50 feet of baseboard that's going to be installed in the space itself. So you have to estimate that length of run of pipe. And we're going to estimate it based upon, hey, I've got 50 feet and I have a little bit more after that. And we come up with about 85 feet. We're not looking at whipping out tape measures. This number should end in a 5 or a 0, all right, in order to find out your total run of pipe, because now what we need to calculate is the head loss to push the water through that pipe. All right, what's the resistance of the pipe itself? So the quick way is now to take that number and multiply it by 1.5. We're going to make it 50% longer than what we actually estimated because we don't know how many elbows and valves and fittings and stuff might be in the system itself. We might see a couple of them back down in the mechanical room, but we don't know how many are upstairs. So every piece of baseboard you have to think about may have a couple of elbows on it. Could be 2, could be 4, could be none, because they might have gone straight through the wall. Maybe in the earlier projects that we used to see, they used to bend the copper pipe. We don't know. And homeowners, in order to size a circulator, if you walk into a house with a Sawzall, homeowners aren't going to be happy saying, hey, I need to count up the number of elbows that are in here. All right, so we're going to estimate that. So that's where the 1.5 comes into play. Now this next number, 0.04, comes to us from the Copper Tube Development Association. And what they state for every foot of pipe running maximum flow for that pipe size will have a head loss of 0.04 foot of head. All right, so 3/4 inch copper pipe running 4 gallons a minute, meaning the maximum. All right, and it's 12 inches long, will have a head loss of 0.04. 1 inch pipe, 12 inches long, running a flow of 9 gallons a minute, will also have a pressure drop of 0.04 foot of head. All right, and this is our estimate. And we're probably going to be a little high on it because we're estimating this on the maximum flow. All right, our example is looking at 2.8 gallons a minute. We're estimating the resistance to push that water through the pipe based upon 4 gallons a minute. So my circulator demands come in at 2.8 gallons a minute at 5.12 foot ahead. That's your flow and head calculation. That's it. That's it. Or let's round it up to call it 3 gallons at 5. All right, because we know that 5.12 is probably way oversized by at least 40%. By at least 40%. So now we have some place to start on calculating whether or not you need to, are you going to run out of capacity with the circulator, or can I put more zones onto that circulator itself? And that's when we come and take a look at pump curves. So here you're going to see a few performance curves out there. This is looking at the 008 and smaller. So curve number 6 here is showing our 008. Curve number 5 is our 007. There's a 005, couple 006s, and a 003. What you look at here is your flow is across the bottom and the head loss is on the left-hand side, and you plot out what you know. So 3 gallons a minute, 5 foot ahead, X marks the spot. That's our design. That's what you needed to do. Now you go ahead and choose a circulator that's going to give you that flow and head. So as you can see here, there's no circuit that lands right on the line itself. All right, you have the 003, which is kind of close, and you also have the 006 circulator right here that gets also close. So you could choose that as well. Now, one thing that's important when sizing your circulators is this blue curve, this blue line that I put up here that intersects all of the pump curves. That's your system curve. And we've done some webinars on that many, many times for Takeo Tuesday, as well as our Takeo After Darks. And this goes through the point that you've calculated, starts off at 0, 0, and we do a curve. Now, there's a formula that you can do it. There's a couple of apps that you can download. There's the system sizer wheel that you can use in order to find the points of this. The point of this curve, the reason why we draw this on here is depending on what circulator you choose and where the line intersects, that's the performance you get. So I know a lot of people here may have, what circulator would you choose right now? If this was your system, your design right now, what circulator would you choose for this project out there? And if anybody has any questions whatsoever, of course, type them in there. John and Jason are monitoring the questions. They will interrupt me as we go through. John loves doing that a lot of times. So Joel going with the 006, yes, definitely. Yep, that's probably the closest one to get there. So sorry, just had to check out something else. All right, so things are looking pretty good. So what would you use? What would you use out there? All right, so Joel's going with the 006. All right, now you probably could get away with the 005, believe it or not. I'm sorry, the 003 operating down here. Because remember that this point is probably 40% too big on the head loss. It's still going to be 3 gallons a minute. So could we drop it down to say around 3-4 foot ahead? Could easily get away with that, and it would probably work. Now, if that was too small of a circulator, how would you know? How would you know if you installed this circulator in there and you really needed 3 at 5, and if you put the 003 in there? How could you tell that this system's not working? Well, the first thing you're going to do, or the first reason why you're there is because it's starting to get cold upstairs in the house. Now, it doesn't mean it's ice cold in the house. It just means the temperature drops a degree or two from standard settings that the homeowners are expecting. But you go downstairs, you take a look at the mechanical room, you see the circulators circulating, the boiler's boiling, right? Everything's going on in the system the way it's supposed to. What you do check at that point would be your delta T, right? And then what is the outside design temperature? So, if your outside design temperature is 0 degrees and you're at 0 and the delta T is more than 20, then your circulator ends up being too small or the head loss is higher than expected. All right. So you'd have to double check it that way and find out that would make a pump too small for an application. If you chose the 006, all right, like Joel was saying here, you'll end up with where the 2 lines intersect is the actual performance you get. So you will deliver about 7 foot ahead and about 3.5 gallons a minute, and everything would work out perfectly here. The challenge that you run into is trying to find a 006 cast iron flange circulator. All right, I've never seen one in the wild. We do have a part number for it, but I've never seen one out there. So we do make them, just not often. So what ends up going in most of the time that we're going to see it is going to be our 007. So the 007, if you drop that in, understand that you're going to deliver about 9 foot ahead and over 4 gallons a minute, close to 4.5. And that's okay too. We're not going to overheat the space. Things are going to be fine in the house. Everybody's going to be comfortable out there. Now, what you might want to stay away from would be, say, the 008, because where the 2 lines intersect here is going to be about 13 foot ahead, and you're delivering about 5.5 gallons a minute. So you're giving about 40% more flow out to the system. And the further you get away from your design point is where we see issues come into play, where we start hearing noises, too much flow. It just doesn't do anything for you by going with a bigger circulator. If anything, it worsens the system by decreasing your delta T. And by shrinking that delta T, now all of a sudden we're starting a short cycle in our boiler, right? And that's not what we want to see. We want to, when it comes to hydronics, we want to see slow and gentle heat. We don't like to see fast and furious. So that slow and gentle heat is going to give us what you need. All right, we don't want to slam it in there in less than 10 minutes. We want to do it in a little bit longer of a time period. Okay. Michael comes in here and says, could you use the 007E and ramp down the speed? We're going to pull up the 007E's curves in a minute, Michael. So excellent question. So I will show you the E series circulators as well as the 15 and also the VT 2218. So why zone with circulators? Why do we zone with circulators? There's many, many reasons out there. And those of you that did answer that you zone with circular, why? What was your reason for it? All right, I'd love to know what your reason is. The biggest thing is why not? Why not zone with circulators? All right, they are darn reliable. One thing I have learned about the our circulators out there, what we manufacture anyway. I spent some time with the engineers when I started at Taco, and they said that these we designed to last a minimum of 250,000 cycles. So, which equates to about an 18-year lifespan in a single zone system. All right, one pump, single zone, one thermostat. That'll last about 18 years. That's the estimate that we got out of it. So that 250,000 cycle count does take a long time. All right, so you do get that reliability out of these circulators. You also get a lot of redundancy as well. All right, so because, like I said, 18-year lifespan, if you start putting more and more circulators in there, you end up reaching that 250,000 cycle count a little bit faster. All right, you're not going to get to that 18-year time span because the circulators kick on and off a little bit more often. So when circulators fail, all right, and hit that lifespan, I still have heat in the rest of the house. So that's what I mean by redundancy out there. And as you saw, pretty hard to undersize. Pretty hard to undersize. A lot of our zones we're doing with 3/4 inch pipe, 4 gallons a minute maximum flow. If we come back to that pump curve, you'll see that we stay way below the pump curves, way below the pump curve. So it becomes very hard to undersize a system when you are zoning by zone circulators out there. However, some people love to push the limits. All right. Actually, I'm sorry. This is not a zoning system. This isn't a building or anybody's house. This is actually our circulator farm. All right, where we start growing circulators. And once they become ripe, then we pluck them. But how do you know when they're ripe?
So they start to sprout little flowers, I think. I'm not sure.
They turn green.
Oh, just like a pepper. All right, I got you. Thank you. Thank you.
So you can see a couple here that have been plucked. All right, this one right here in the front's been plucked. This one in the middle. This one all the way in the back there. And you start when you start having to pluck the ones in the back. That's when you start looking at your crew and you start looking at the smallest guy that you have that you just hired, saying, "Hey, we got to get that one. I'm taking care of this one right in the front." All right, but we got other people hitting the ones in the back there. Okay, and the only reason why I know these are the newer ones because I could see the labels turned white sometime in the early 2000s, and these were dark green ones in the late 90s or so on the stickers that we had on them. And now, when we look at the circulators today, the label actually ends up on the end of the motor itself. But anyways, so why zone with zone valves? Why do you like to zone by zone valves? So those of you that answered that question out there and put zone valves in there, all right, why do you choose zone valves? I mean, 60% of you chose zone valves. So again, the reason comes down to why not. All right, they are darn reliable. They are a lot more reliable than when they first came out. And when I was starting in the industry doing a lot of design work for people and everybody came in my office and said zone valves suck, all right, I had to understand why. And actually I did some research and guess what? Zone valves did suck. All right, and the manufacturers back then would tell you to put the zone valves on the return side of the boiler. And when I talk about back then, I'm talking 50s and 60s and 70s. And if you ever go to a job site today and you see some really old valves on the system, something that's been in there for the last 30, 40 years, that's not a quarter turn ball valve, what don't you do to that valve? Yeah, you don't even look at it. You don't breathe on it. definitely don't turn it, right? Because now all of a sudden you start thinking about how that valve, it starts leaking on you. And it usually comes leaking through the stem itself. Those old designs of those valves, all right, any valve, all right, you had, in order to make it watertight, you had that packing in there. And then there was a packing nut on top. And if you open and close the valve a few times, that packing would get a little bit tighter, so to speak, or looser, depending on how you look at it. And you needed to tighten down the packing nut. But remember this, how much do you tighten down that nut? And I'm sure, John, you touched a few of them in your day, right?
I really don't want to talk about it because it never worked out well for me.
Right, exactly. You
Certainly
start
not
to
on a
take,
Friday night, not on a Friday afternoon.
no, definitely not. No. Yeah, only on a Friday morning if you knew you had the day to work, right? Because as soon as you touch that valve, it's leaking. You got to tighten down that packing nut. How much? Just enough. All right. So those zone valve manufacturers were asking us to put the zone valves on the return side because they wanted to see cooler water. But that was also when boilers were boilers. All right. When we would sit there at 200 degrees, 210 degrees. Today we're lucky if we make it 180. So today we're more water heaters than anything. But we can't call them a water heater because that's the round thing in the corner. So the reliability of zone valves have changed tremendously over the last 15, 20 years. They can be less expensive when you start thinking about zoning out a system itself, okay? Because now you're limiting those flanges and line voltage wiring. Now we're going to low voltage wiring, easier maintenance because you can easily change out a power head. The valve body doesn't change itself. Today, we're looking at zone valves that have a ball valve with a motor put on top of it today. All right, so that technology is a better proven, right? And we also can look at less space. Our boiler spaces are getting smaller and smaller. Here you can see 4 zone valves in a very short amount of space, maybe the length of my arm between my elbow and my wrist. Try to put 4 pumps into that space and make it serviceable. I'm not saying you can't do it. I know people that can, but you will never make it fully serviceable like you can on a zone valve system. Yeah, Mike saying, yeah, on a Friday at 4 p.m. and the supply house is closed. Yeah, don't touch that valve, bro. That's right. Yep. But we also start thinking about using much less electricity by going zone valves as well. Okay, so circulators, 120 volt circulator, 80 watts for a 007, 85 for a 3-speed. Now you get down to the zone sentries like this at 1.5 watts. All right. So we do a lot of training classes and we talk about fuel consumption and trying to make sure the boiler uses as least amount of fuel as possible. But then sometimes we never pay attention to the electrical side of things and how much, because most people are saying, well, this is how many pumps I need, period, done. All right. Maybe we can do zone valves instead and really start dropping electrical load that way. So, but I know the conversation already comes up there, right? We start talking about, well, if I've got 1 pump and 4 zone valves in the house and the pump fails, I've got no heat in the entire house. But if I had 4 pumps in there and 1 pump goes down, I still got heat in 75% of the house, right? But as you heard me say, 250,000 cycles, all right, you're getting pretty reliable with your circulators. And here's also the other thing to think about. All right, you're looking for that redundancy in there. But if a circulator fails, whether it's zone valves or zone circulators, are you still getting a phone call from the customer saying, I don't have any heat? Well, you don't have any heat in 25% of your house, so don't go there. All right. You're still getting a call. You're still going out to the project, and you probably have a circulator as a spare on your truck, right? Or you would definitely bring one with you anyway. So you're still showing up to the house and being able to fix the system. Now, again, your customers, your customer base and how they work, and maybe you've got a customer that is 2 hours away from you, and the heat goes down on a Friday night in that one zone with 4 pumps in it. All right. Yes, you can say, all right, I'll be out in the morning. But if you had that 4 zone valves in 1 pump and the pump goes down, they have no heat. Well, now you're heading out there. So again, you know your customer base when it comes to making those decisions, whether you go zone valves or zone circulators, right? So, but like zone circulators have their issues, zone valve systems also have their issues if not done properly. Okay. The picture here on the left-hand side, this is what I call the Rube Goldberg job, where they just keep throwing stuff at it to try to make it work. All right. So you'll see here, we got a bunch of 570 series zone valves, 1, 2, 3, 4, 5. And I think there's one more hidden behind the expansion tank and one circulator. And it's not like it was undersized, that the circulator was the wrong size or anything like that. The problem here is because he had 1, 2, 3, 4 mixing valves in this project, the circ was just on the wrong side, but they kept on throwing things at it to try to make it work. All right. And here's the other challenge that we always see with zone valves. All right. Just the wiring aspect of things. Wiring gets confusing, low voltage. A lot of guys don't like to do the low voltage. And if there's any wiring that's happened, I just get the electrician in there and he can easily do the black and white wires from circulators and call it a day. Okay. So challenges are there too as well. But let's take a look at the 570 here for a second. All right. Now the 570's one zone valve is a 3/4 inch sweat model. It's got 3 terminals on there, 2 for power, and 1 more for end switch on there. All right. These are slow acting. We've been making these things in some form or another since the 50s. All right. So, but the 3/4 inch sweat is an important number to know because it also has, all zone valves have a rating on it that we call CV. And the CV is a flow coefficient, which means it's a pressure drop calculation that's done. And it's based upon the valve body design. All right. What is the pressure drop through the valve? So when you see the CV value, this says I could pump 6.1 gallons a minute through this valve body and it will create 1 PSI pressure drop. Now we did our head loss calculation before in foot of head, all right, which 1 PSI equals 2.31 foot of head. So that's an additional on top of the head loss calculation that we did before. That calculation we did before was just based upon the 3/4 inch pipe and the length of it and the elbows that are there. All right, so what you would have to do is take that number, and if you put zone valves in it, what's the pressure drop through this valve body, and add it because this is in series with that system. So a high CV value like 6.1, we're never going to pump 6 gallons a minute through a 3/4 inch valve. We're typically around 4. So the equivalent pressure drop of this valve, if you were to run 6 gallons a minute, is like adding an extra 20 feet of copper pipe in that pressure drop calculation, like I did before. It's not much. Now there is a formula for it, and I'll bring that up in a second. Let's take a look at the Zone Sentry. And the Zone Sentry here is a ball valve, much different design than any other zone valve out there. It's a ball valve with a motor on it. And the reason why we like to put ball valves in our system, low pressure drop, doesn't affect our systems, designs, anything like that. The 3/4 inch Zone Sentry has a CV at 10.2. 10 gallons a minute will get you 2.3 foot of head loss. All right. And we're never, ever anywhere near that on a 3/4 inch valve. Now, here's the formula if you do want to do that calculation. And it says your calculated flow divided by the CV of the device, then square it. Now multiply that by 2.31. That will go from PSI to foot of head. That gets us our additional head loss into the system. So if we use the Zone Sentry, for our example, 2.8, it was our gallons per minute flow that we calculated earlier today, divided by 10.2, square it, that gets us 0.08 PSI as a pressure drop. Multiply that by 2.31, it's 0.18 foot ahead. 0.18 foot ahead. It's almost like it's not even there. All right. Again, that's why we like seeing these zone valves being used in systems, because it's a ball valve, very low pressure drop. So if I were to do the calculation, it comes in at 5.3 foot of head compared to 5.12. Again, not really changing much for you. Okay. Now, what I do want to point out, a lot of zone valves out there do have a CV of 3.5, and you might look at them and they could be very, attractive to use because of price point, stuff like that. What does a CV of 3.5 do for you? Well, if we do that same calculation, 2.8 divided by 3.5 gets a 0.64 PSI. It's an additional 1.5 foot ahead. Now, in our example, probably not going to affect us whatsoever because we ended up with, say, that 007. All right. But if you're on the line or really close to the line and then added zone valves, then you could see that widening delta T on your system or that short cycling of the boiler when you start looking at it. So it is important to pay attention to. So what I like to say, the point of the story here is when you're using zone valves, go with a high CV. A high CV zone valve is going to give you less pressure drop across the valve body itself and keep you safe in your circulator sizing selection. Does that make sense out there? So we're at this just over 30 minutes or so. Everybody, just want to make sure that everybody's with me. How's the pace? How we doing out there? Any questions you want to hear out there right now? And then, Michael, I still have your question. It's coming up when we start talking about 007E.
Can I throw something in there, Dave?
Yes, sir.
When you're talking about CV for an on-off valve, like a zone valve, you go for the highest CV you can. As Dave said, high pressure drop equals low, high CV equals low pressure drop. If it's a mixing valve, like a motorized mixing valve, like a three-way valve or something like that, you want the CV rating to match your flow as best you can. This is a different topic, and I think it's worthy of a webinar later on this year. But with a motorized mixing valve, you have something called valve authority, and you want to make sure you have a consistent mixed water temperature. So for mixing, like a three-way valve, you want a CV that matches the flow rate as best you can, and maybe even a little under, you just deal with it. But for an on-off valve like a zone valve, yeah, the higher the CV, the better, because that's the lower pressure drop.
Right. Excellent. Thanks, John.
I'm here to help, Dave. You know me.
Jason, feeling good?
I'm feeling good. Not a lot of questions coming in, but we'll see.
All right. So let's say now you've got a zone valve system and we need to size that circulator. So you got to do the math. And one of these days, I am going to get that clock and put it on the wall behind me. I need one of those clocks. So anyways, and yes, and John, you're looking at me like, yeah, if anybody had it, it would be me, right? So for a little review, zone 1 is 2.8 gallons a minute, 5.12 foot ahead. Now zone 2, second floor of this house, happens to be 3.9 gallons a minute, higher head loss, but we end up with a lower head. All right, higher flow rate, lower head loss, because the second floor, instead of being baseboard here, we put in a fan coil. All right, so we have a lot less pipe going in the system. It's not going around the perimeter of the house. So your head loss is a little bit lower. So what we need to do is size a circulator that can handle when both zones are running at the same time, because there will be that instance. That instance will happen when you need to flow both zones at the same time. So let's make sure the circulator is sized enough. So for everybody out there, what would be the flow and head? What would be the total flow and total head that this circulator needs to be sized for? All right. So we have a couple of answers out there. I'm just curious as to what everybody is thinking out there on what the math needs to be. And if you need to round up the numbers and round them down, let's call it 3 gallons a minute at 5 and 4 at 4. Okay. What's your flow and head? All right. Again, 3 gallons, 4 gallons, 5 and 4 foot ahead. All right. Out there. What would you need that circulator to do? So, and I think you guys are already on the same pace as I am, where I said that, the flow is your heat, right? You go back to that universal hydronics formula, BTUs, so to speak, equals GPM. The bottom part of the universal hydronics formula becomes a constant, right? 20 times 500. So when you really stop and look at that formula, BTUs equals GPM, all right? So in order to get that heat, I need to add up the flow. You definitely have to add the flow because there will be an instance both zones are running at the same time. The only time you don't have a zone running at the same time is when you put the system into priority. And the only time we typically put priority in the electronics is if you have a domestic hot water zone. We're going to turn off the heat zone and just get hot water quicker. I have never seen anybody put a priority zone on a heating zone in a house. and say, well, you'll get heat to the second floor as soon as the first floor is done. All right, people don't like that. So especially when it comes to hydronics and we're doing slow and gentle. So you need to add the flow up together. However, head loss is not cumulative since this is a system running in parallel with each other. All right, what you need to do is you find the highest head, and then therefore that is what you're sizing your circulator on. You're going to add the GPM up and then find the highest. Head is not cumulative. It's only cumulative if it's in series with each other. All right, so John's dropping in there 6.7 at 5.12. You are correct, sir. All right, so that is the flow and head that this system needs. All right, because we're not adding up the head. All right, and if I had high head zone valves in here, I would have to change those numbers to account for the pressure drop through that zone valve as well. So that's why right here at 5.12, couple zone sentries, very minimal. I would never break out the calculations and roll because I already know that these numbers are already going to be high, right? Again, this is about 40% too big in my head. The flow is accurate. The head loss is not that accurate, but it's estimated on the high side. So that's my total flow and head. So we come back to here, all right, and now you plot it out again, close to 7 gallons a minute, 5 foot ahead. All right, you still see that we're well under the curve of the 007 and still under the curve of your 008 as well. Still could have gone pretty close to that 006 that Joel was talking about earlier. All right, now the 003, yeah, that's probably going to be too much pump, too little of a pump. All right, that you would not be able to heat the house probably 40% of the winter. The delta T is going to be too wide, and therefore we're not just delivering the right amount of BTUs out to that space. So, but 60%, hey, we're fine, right? But as soon as it starts to get real cold out there, that's when it starts to be affected. So you can see here again, now if I did drop in the 007, we deliver about 8 gallons a minute at about 8 foot ahead, and this is still pretty darn good. Still pretty darn good. And there it is again for our single zone system. If the zone valve closes, now remember it's going to back up to here. All right, so if you had 2 zones open here, all right, we have 3 system curves when it comes to a zone valve system. You have zone 1 by itself, zone 2 by itself, and zone 1 and 2 together. So in essence, what happens is it operates at 3 different points. So here is all zones calling. Now this is where one zone is calling, and if we had our 4 gallons a minute, 4 foot ahead, we would have another curve that would fall right through here, and this would be my flow and head. So we'd be operating at about 6 gallons a minute instead of 4, and delivering about 9 foot ahead. So very close with that 007. Very different when we start looking at steep curve pumps, okay, that the flow and head changes a lot, okay. But what about 3 speeds? Let's talk about 3 speeds, because what's great about 3 speeds?
It has 3 speeds.
You got 2 more. You got 2 more. You've got the settings on this circulator, like you see here. No, 1 is low. Nobody does low, right? That's for beginners. You know, they just entered the industry. They're not sure what they're doing, right? Medium is for people that they're just not sure. They're just not sure. It's a small zone, but it's a little big. I'm not sure. I'm just going to put it on high always, right? Because that's what we call here contractor no callback speed, right? If you don't know and you didn't do the math, it always goes on high, right? So let's take a look at the 3 speeds. And the 3 speed, the common residential size circulator, is going to be the 0015 3-speed circulator, the blue curves. The red lines here is our 0010 3-speed. So this is one we've had out for a lot of years. And this is that great for that system where you're looking at your old B&G 100, the Takeo 110, your big 3-piece circulators. And that is actually your good choice for replacement of those. Again, if you don't do the math and you're not sure what you need. But the 0015 is the more common residential circulator. So let's see, what setting would you put it on? And if you're doing your zone valve system, all right, with 2 zones in it, 6.7 gallons a minute, 5 foot ahead, and then you look at the blue curve, all right, we probably could get away very, very easily here on putting it on low. Again, remember, 40% oversized on that head. All right, putting it on low is going to be more than enough. Medium gets you all the way up here at about 7 gallons a minute at about 9 foot ahead. But when you drop it on high, now we're sitting there at about 8.5 gallons a minute and almost 12 foot ahead. Okay. So the further you get away from your design point, your delta T starts to shrink. And we also may start hearing velocity noise in our system. So we always want to be close to that design point that you've calculated when it comes to circulator selection or speed selection at that point as well. And if you're a zone pump guy, if you're doing zone circulators and you're using 3 speeds, I would say 99% of the time you can put it on low, especially when you look at that header and it's all 3/4 inch pipe. Remember, 3/4 inch pipe, 4 gallons a minute. We live in this world. This is where we live in our zone sizing because we do a lot of 3/4 inch systems. So we are from 4 gallons a minute and down, and low head loss. Low head loss. Remember, the head loss was calculated based upon maximum flow of 4, and we're going to be hanging out probably way down here all the time. So easily get away with that low setting. All right. So now let's talk about some of our 3 speeds, and you'll see here our 007E, the 15E, the 18E, the VT2218, our residentially sized circulators. We do have ECM circulators, variable speed circulators that go all the way up to 320 gallons a minute, up to 65 foot of head. Okay, so but let's stick with some of the smaller ones here, the more common that we're going to run into. And if we start off with the VT2218, this circulator here is a delta T pump, so it has a pump range that it operates in. So A is the minimum speed, B is the maximum, and it's going to run somewhere in the middle. And this is using 2 temperature sensors to maintain that 20-degree delta. So on a design day, both zones are running 7 gallons a minute, 5 foot ahead. That's where you're going to run. It's going to give you the exact flow you need. So if you were ever to want to pick a circulator where you don't have to do the math almost self-sizing, I always still want to do the math. As we showed you today, the math isn't hard, all right? But this is darn close to self-sizing that's out there when you look at delta T, because it's maintaining that 20-degree drop in the system itself. So on a design day, it'll run up here. As it warms up, the circulator will actually slow down because my delta T is starting to shrink. And as the delta T starts to shrink, I don't need as much flow. So therefore, it maintains a level of consistency in air temperature in the house upstairs. And now when your zone valve closes, it will all of a sudden drop to there because the delta T starts to shrink and it slows down to this point. All right, so just remember that you can't go any slower than slow. All right, so you will hit this bottom end eventually and operate on curve A. It doesn't work in the white shaded area down here. All right, it stays in that green spot. So you have the chance to ramp all the way up to here. All right, but now we're looking at a nice, quiet, and very consistent system with a delta T design circulator. If we take a look at the 007E, which is very close to our 007, it doesn't do all the way out to 23 gallons a minute. But as we talked about already today, do we need 23 gallons a minute out of a 007? So, like I said, we're sitting here at the 4 gallons a minute range on zone pump systems, maybe 8 for a couple of zone valve systems. So for our example, and I noticed this typo about 5 minutes ago, but right before we started, that this dot right here should be over one line right to here, all right, and it will hit right at the knee point of your 007E. So it's really darn close to your flow that you would have had with a 007. All right, so the flow is really close. We gave you a little bit more head here. We just took some away on the back end, gave you a little bit more on the front end here, but pretty darn close when you start looking at your performance curve and your system curve operating in the system. Now we start looking, the beauty of the 007E, all right, the 7E doesn't have any dials, doesn't have any settings on it, but it does vary its speed when the circulator runs. When it hits the diagonal yellow line, meaning your system curve hits the pump curve, it is running full speed, full out. When it hits the flat portion here, now it's starting to slow down. So it's automatically speeding up and slowing down in this system. There's no dials on it. All right, it is just a set circulator, but it is a delta P circulator. It is going to change its speeds as the valves open and close in the system itself. And it does that by an amp draw and an RPM speeding reading off the circulator itself in order to figure out what speed it's going to do. And again, if you're smaller, it just starts to slow down to there. Now we take a look at the 0015 E3 circulator. So when you set that circulator on high, it runs the blue curve. So you probably don't want to run it on high, as we talked about, right? And if you set it at low speed is this orange curve right here at 5 foot ahead and then out here on the blue curve. That is your maximum speed the circulator is going to run at when you set it in low. And 7 gallons a minute or 6.7 at 5 foot ahead, it's going to operate right there on that line. Now it's going to operate just like the 007E, meaning it's a variable speed circulator. Yes, you have 3 settings, low, medium, and high, but in each setting in low and medium, it becomes a variable speed pump, and it's going to operate on the curve. So if I had zone valves, both 1 and 2 were open and valve 1 closed, it's going to bang back to that 3 gallons a minute, 5 foot ahead. So here it bops, all right, based upon the number of zones that you have. So now it actually becomes a 3-speed pump because it changes speeds on its own. Zone 1 by itself, zone 2 by itself, zones 1 and 2 together. All right, this becomes a 3-speed pump. It's 3 settings, but 3-speed, as in it does change its speeds automatically, just like the 007E does. If you were to put it at medium, it'll operate up here on 10 foot of curve. So it would be, again, right there at that knee point, like I was showing you on the 7E. All right, then it drops down to here. It's going to hit about 4 gallons a minute, 10 foot ahead, and so forth. All right, so now it would become lowering power consumption. Instead of hitting out here at 44 watts, we're down here, all right, maybe around 15 to 18 watts, down here at about 6. So now we're starting to really cut down the power consumption, taking advantage of what the circulator can do, but I don't need all of it all year round. So now it becomes that variable speed circulator to match the system demands. All right, how we doing out there, everybody? Feeling all right? Anything, any questions come in? I know I was talking really fast there for a little bit. I'm not sure if anything came in.
I think you dazzled them, Dave. There's 72
well
people
done.
out there. You just dazzled them, man. I think I know you stressed this, but me being me, I want to stress it again about variable speed pumps. Is that, you know, you look at the VT2218, I think you have a circulator there that will size itself. It's as close as we have to a self-sizing circulator. Your Delta P pumps, but by Taco or anybody else, even if they have an auto button on them, they don't size themselves. They work on pre-programmed algorithms and things. A lot of people still to this day, you and I have had this discussion often, Dave, is that, you know, people say, oh, I just put it in auto and it sizes itself. And that's not what it does. It's not even close. It's still going to work on a programmed setting. And the only way anything on an auto mode will do anything is if it's running all the time. We have it in our own 0018E. It has to run continuously or it never really does adapt. Once it stops adapting and it's got to start all over again. So it is really important to understand that, you know, what you're holding in your hands and what it really does. Just because a pump is variable speed doesn't mean it always gives you the right flow or the correct flow or the flow that you need. It'll just vary its speed based on external input. And in the case of the 007, that circulator is always going to work on that yellow line that you see right in front of you. It's not going to do anything else. As system curves intersect further to the left, as Dave's showing here, yeah, that pump's going to slow down, but it's always going to be a 10 foot ahead constant pressure operating mode. That's just the way it is. Not to say it shouldn't use them, just to say that's understand what they really do. So in this case, as Dave's showing, if you need 8 gallons a minute at 7 foot ahead, well, you slap the 007 on there, you're never going to see 8 gallons a minute at 7 foot ahead. when all zones are calling, you're going to have that pump running at 44 watts at what looks to be about 9.5 gallons a minute at 8.5 feet ahead, or almost 9 feet ahead. And it's going to do that all year long. The VT2218 is going to speed up and slow down as zones open and close. It'll also speed up and slow down as it gets warmer or cooler out, because it's inferring the load based on the delta T. So there you go.
Excellent.
All
Thanks,
stuff
JP.
you already said, Dave. All stuff you already said, but you know me. Why use a sentence when there's a perfectly good paragraph hanging around and I can repeat myself over and over again?
That's right. That's right. Yep. I know. All good, JB. All good.
I'm sure you see this already. Jim asked if there's a handout or sample calculations. Obviously, you can't give the slide deck away, but do we have a data sheet that we can? Is there a handout?
Yes, we do. So what you can do, John, is you can download our residential catalog, and in the back of that catalog is an index that does show you these formulas and calculations and example circulator sizing. So we do have it built into that.
Hang on, I'll get the link. So don't go away, guy. Don't
There
go
we
away.
go.
Okay. What you will also get in 23 hours time is that you will get a follow-up email from this presentation with a link to the video, so you could go back and watch it again in case you miss us and you want to watch it again. You can definitely do that and share with all your friends and family, right? And show what you guys do for a living, because nobody really knows what we do. We just know that, oh, you guys are plumbers, right? Type of thing. So you can get that from there. Also on our website, I know John is looking for one thing. We do have another place. Let me pull it up myself as we're doing it on our website. When you go to training and you click on, let's see here, you go to the training section, click on the words right there where it shows online training. All right, when you click on online training, you will find training documents all the way to the right-hand side. All right, and you'll find some of our things that we have there, and probably one of the things you want to download is going to be our takeaways brochure. Okay, and maybe I can share my screen for that instead. Let's see here. I will stop sharing my screen for a second, or I can just change to a different screen. There you go. Let's see here. Yeah, so you click on training, go to online training, click on that. Don't come to Takeo Tuesday. All right, you want to click on the online training and you will find the takeaways brochure right there. Or you can also download the step-by-step cheat sheet that we had. That's also in there as well. And a lot of this other stuff is for some of our piping classes and some of our wiring class, recirculation classes as well.
Oh, by golly, there it is right there. I don't have to be, I can't find the product catalog. That's because I never know where to look on here, but that'll have everything you need, what Dave is showing you right there.
Yeah, right there. Yep. So you can find it right there, Jim. Hopefully you got that. And if not, I will put that. How about I do this? Copy, and I will send it to you right now. There you go. Excellent.
Bada bing.
Now, what I do want to bring up real quick is next week's class. Next week, obviously, we switch back over to commercial. So you're going to see Rich and Brett and Tony, either one of them or all three or any combination thereof out there. And they are doing an introduction to our HSS software. So the hydronic solution software, where you can go ahead and design your hydronic systems, commercial applications, not a residential size. But if you haven't used our HSS yet, they're going to give you a quick introduction and how to get it, how to get your hands on it, and also the stuff in between, and how to get started with that software. So if you haven't signed up just yet, go almost right back to that website on where I was before, and you can go take a look at training, take a Tuesday, and register for one of those classes.
And
Excellent.
we one more thing. We have a very cool thing coming up on July 23rd. Shall we tease that, Dave? You want to tease that now or what?
You kill me, bro.
I know I'm killing you because I'm holding us accountable. If we talk about it, we have to do it.
I told you we couldn't be accountable until after today. So
don't wind him up, John.
First, dude, we had to figure it out first.
Figure it out first. I know. I'm just, you know me. I am more than willing to write checks that you are going to have to cash.
I know.
Just be on the lookout, folks. Be on the lookout. I believe something really cool will be coming your way, Takeo After Dark wise, as early as July 23rd. It could be sometime in August. Thanks. See what I did there? As early as July 23rd.
If looks could kill, John.
It's not just me. Other things that have to come into play to make it work. So I'm still
That's all right.
waiting.
Potentially as early as July 23rd, something new, exciting, and different will be coming your way.
Are you getting ahead there, Dave?
Regarding Takeo After Dark. That's all I'm going to say.
I love my job. I love my job.
You have to rock back and forth when you say that.
Yes. I love the people I work with. Yes. Anyways, so yes, we're looking at doing some fun stuff with Takeo After Dark. Yes.
It'll be a good time, Dave. You know we're going to get there.
I know. Yep, I know. Well, with that being said, everybody, we do say thank you for spending some time with us today for another edition of Takeo Tuesday. Greatly appreciate it. You know, we do know there's one thing that is probably the most valuable thing out there. All right. And it's not water and gold and all this other stuff. It is coming down to the value of your time. All right. We want to make sure that we're not presenting, giving a big old sales pitch to these things. We want to make sure that we give you the information that is useful for you so you can go out there tomorrow. Well, you can go design a system tomorrow, maybe not install one. All right. So tomorrow is going to be people working on AC, especially back here in the East Coast.
Yes, indeed.
Anyways, we do greatly appreciate you guys stopping by and hanging out with us for an hour.
Thank you very much, folks.
John, thank you very much.
Thanks for the laps, guys.
And to Jason and John, see you guys later.
Peace.
You have a wonderful rest of your day.
You as well. Peace out.
You as well, sir.